Hey everyone, and welcome to The Explainer. Today we're going to dive into a problem that sounds super simple but is actually surprisingly tricky: cooking your lunch using just the power of the sun. It seems like it should be easy, right? But as we're about to find out, the secret to success all comes down to one tiny, crucial detail: shape. So, to set the scene, let's meet our main players. First up, we've got Kaju. He's a really bright entrepreneur who's just launched a new company making solar-powered gadgets. And then there's his uncle, Daduro. He's come to check out the new factory, but honestly, he's got one thing on his mind. And one thing only: he is starving. So Kaju, trying to show off a little, promises he can whip up some dal in literally 2 minutes with his amazing new solar cooker. But there's a problem, a big one. An hour goes by. The doll is basically still just sitting there, and Dowdorow's patience has completely evaporated. Kaju's big product demo, a complete and utter flop. So, what on earth went wrong? Kaju is just scratching his head. I mean, he did everything by the book. He built what should have been the perfect solar machine. How could such a simple plan fail so badly? And this is the really interesting part. Kaju was so sure he was right. He designed his cooker with a perfectly spherical concave mirror, the exact kind you see in every single high school physics textbook. On paper, this should have been the absolute perfect tool for the job. All right, let's get into the physics that Kaju was counting on. Why did he think, and honestly, why would most of us think, that a simple curved mirror would create a super hot spot perfect for cooking? Okay, so the logic here seems totally solid, right? First off, the sun is incredibly far away, which means its light rays are all coming at us pretty much parallel to each other. Now, a concave mirror is supposed to grab all those parallel rays, bounce them inward, and concentrate them at one single spot, the focus. That one tiny point should get intensely hot, definitely hot enough to cook dal in a few minutes. It's the perfect setup. So, where's the heat? Well, it turns out the problem isn't the sun at all. The problem is a subtle but absolutely critical flaw in how spherical mirrors actually work in the real world. It's a little detail that most of those simple textbook diagrams just kind of gloss over. And this little glitch has a big name: spherical aberration. You can think of it as an optical bug in the system. To put it simply, a perfectly round spherical mirror isn't actually perfect at focusing light. The rays that hit the wide outer edges just don't go to the same place as the rays that hit the middle. This slide shows exactly what's going on. The light rays that hit near the center of the mirror, we call those periaxial rays, they behave pretty well. They reflect and land more or less at the focal point. But the rays that hit the outer edges, the marginal rays, those are the troublemakers. They bounce in at a much sharper angle and completely miss the target. And here's the bottom line. Instead of one single laser-focused point of heat, Kaju's cooker is just creating this fuzzy, lukewarm spot. Most of that amazing solar energy his big mirror is collecting is just getting smeared out, wasted. It's no wonder the dal is still raw. Okay, so if a sphere is the problem, what's the solution? Well, lucky for Kaju and for us, math and physics have a truly beautiful and elegant answer. It all comes down to swapping that simple curve for a much, much smarter one. And this is the ultimate showdown. It really shows you everything. On the left, you've got our spherical mirror. It's a mess, right? Energy scattered everywhere. But look at the right. That is a parabolic mirror. A parabola has this unique magical property. Any parallel ray that hits its surface, doesn't matter if it's at the center or the very edge, bam, it gets reflected to the exact same focal point. No blur, no wasted energy, just pure concentrated power. So Kaju sees the light, literally. He rebuilds his cooker with this new parabolic shape, and let me tell you, it is a total game changer. And what's really cool is that this incredible principle is being used in places you probably see every single day. Just look at these results. It's incredible. The cooking time for that dal plummets from over an hour to just 30 minutes, a huge success. But of course, his uncle Dadaro, ever the critic, challenges him to get it under 10 minutes. So here's a little question for you. What else could Kaju do to make it even faster? Now, this whole idea goes way beyond the kitchen. In fact, I guarantee you've seen this shape before. Ever really looked at a satellite TV dish? That's not just some random bowl shape, it's a paraboloid, which is basically our 2D parabola spun around to make a 3D dish. And instead of focusing sunlight, it's grabbing super faint radio waves from space and focusing them perfectly onto that little receiver. And that leaves us with one last, really fascinating puzzle to think about. A solar cooker has to constantly be moved to follow the sun's path across the sky. But a satellite dish, which uses the exact same focusing principle, gets installed once and never moves again. Why is that? That's a thought to chew on. Thanks so much for joining us for this explainer.